Hi, welcome to this video tutorial Spring Boot Security Role-Based Authorization with me Namaming from CodeJava.net. Throughout this tutorial, you will learn how to secure web pages in a Spring Boot application by implementing login, logout, and permission assignment for users. In other words, you will learn how to implement a role-based authorization using Spring Security APIs for an existing Spring Boot application. Let me show you an existing Spring Boot project in Spring Suite IDE. You see, there's a product manager project. It allows the user to manage products like view all products, create product, edit product, and delete product. Now, let me run this Spring Boot application to test its feature. Currently, this Spring Boot application is unsecure, and we are going to secure it. Okay, the application is up and running. And now let's test it in a Chrome browser. Localhost 8080. And you see, this is a product manager application developed in Spring Boot. It allows users to manage products like view all products, create new product, edit and delete. Let me create a new product. For example, Kino Fire, brand Amazon, made in USA, price 99. And you see the new product Kino Fire was created here, and I can edit, change the price to 100 and made in China. Save. You see, it is updated, and now I can delete a product. I delete Xbox 360 here. So that's very basic CRUD features of a Spring Boot application. You see, this application is unsecure. Everyone can access its functionalities. And now we want to secure this application by adding a login, logout functions and authorize the users based on their roles. We will be using Spring Security APIs to authorize the users based on these permission details. The users having the role user can view product list, and the users who have the role editor can view, create and edit products, and the users who have the role admin can view, create, edit and delete products. In other words, the role admin can do everything, do all the features of the application. The editor can only view, create and edit, and the role user can view only. And here are the technologies used in this Spring Boot project: Spring Framework, Spring Boot, Spring Security APIs, Spring Data JPA with Hibernate to access the database for the data access layer, Thymeleaf for the view templates, Maven for project build, Spring Boot DevTools for automatic restart and reload whenever we make changes to the code, and MySQL JDBC driver. So that means in this tutorial we implement a role-based authorization using Spring Security, Spring Data JPA with Hibernate, Thymeleaf, and MySQL database. To follow this tutorial, make sure that you have the following software programs installed on the computer: Java Development Kit JDK, Spring Suite IDE, and MySQL database server and tools like MySQL Workbench. And here are the steps which we will follow: create tables, declare dependencies, configure data source, code the user and role classes, code the user repository class interface. and implement the user details and user details service, and configure authentication and authorization. And this is a class diagram. I will explain it to you later very shortly. The first step is to create tables in MySQL database to store the credentials and authorization information like the role names and the permission assignment. For example, we will create 3 different users. The first user, name HM, has a role user. The second user, admin, has a role admin, and the third user, Alex, has a role user and editor. So as you can see, a user can have one or more roles, and a role can be assigned to one or more users. So this is a table entity relationships. We will need 3 different tables to store the credentials and authorization information. The first table is a user's table to store the credentials like username, password, and the second table is store the role names. You see, role ID, name, and because the entity relationship between the user and role is many to many, one user can have one or more roles, and a role can be assigned to one or more users. So we need to have an intermediate table users roles here to implement to implement many to many relationship between the 2 tables users and roles to implement authorization. And now let's create these 3 tables in MySQL Workbench. This is MySQL Workbench. You see the database schema we are working on is SalesDB. Now let's create the first table users to store the credentials. You can see the existing tables, product and customer, to store the information of the application. Now we need to create 3 different tables for the authentication and authorization. Create table, and this table name is users. First column is the primary column user underscore ID. Data type integer pk, primary key not null, and auto increment. And the second column is username, data type varchar 45, not null. The third column is password, varchar 64, because we are going to use Bcrypt password encoding for password. So the size of this column must be 64, not null, and boolean type column enabled. Boolean here, and you see because MySQL doesn't have a boolean data type, it is converted to a tiny int type here. Okay, click apply to create this users table to store the credentials, username, password. Finish. Here we go. The users table was created here, and the second table is store the role, the role names or permission. Create table, and this table name is rows. The first column is a primary key, row underscore ID. primary key, not no auto increment, and the second column is name, the name of the row or name of the permission, not no. That's it. This rows table is very simple. Apply. Finish. And the third table is an intermediate table to eliminate many to many relationship between users and rows table. This intermediate table has only two columns, user underscore ID and row underscore ID. So create the third table. Table name is users underscore rows, and the first column is user underscore ID, data type int. The second column is row underscore ID, data type is int. And these are the two foreign keys to the users table and rows table. Click apply to create this table first. Apply. And click the foreign keys here. And now we create foreign key. The first foreign key is user underscore fk. Reference table is users table. Users and column user underscore ID. Referenced column user underscore ID. And the second foreign key is row underscore fk. Reference table is rows here, or row underscore ID. Okay. And click apply to create two foreign keys. Apply. Finish. So we have created three tables, users rows and user underscore rows, to store the credentials and authorization information. Now we insert some data for the rows table. First, to specify the permission names, select rows here and enter the first row name is user. The second row name is admin, and the third row name is editor. Click apply. Apply. Finish. And you see in this row table we have three rows: user, admin, and editor. And now let's create some users in the users table here, and the authorization information in user rows table. Select rows here, and we input the data for the users table. The first username is namhm. Password code Java enable 1, meaning true. And the second user is admin. Password named enabled 1. And the third user, Alex. Password Alex enabled 1. And because the password must be encrypted in a strong password algorithm like Bcrypt, so we need to write a small program to encode the raw password into an encoded format. So in the project we write a test class in the test folder here, new class, and name of the class is password generator. Click this option to generate the main method. Finish. And because we use Bcrypt algorithm for password format encoding password, so here we create a new instance of the Bcrypt password encoder provided by Spring Secrity API. But you see, there's no suggestion proposals. That means we need to declare the necessary dependencies in the project mom file here. So I also show you the second steps. Second step is to declare the necessary dependency for the project to use Spring Secrity API's Thymeleaf, Spring Data JPA Hibernate in this Maven API file here. And you can see we use Spring Boot Starter Data JPA here. This dependency is required for using Spring Data JPA with Hibernate, and Spring Boot Starter Thymeleaf to use Thymeleaf. And MySQL connector Java is JDBC driver for MySQL. And now let's add dependency for Spring Secrity API's dependency. Group ID is auth Spring Framework dot boot, and artifact ID is Spring dash boot dash starter dash security. This is a dependency for Spring Secrity APIs. Okay, save. And you can also notice that the Spring Boot dev2 dependency is used. So whenever I make changes to the code, it automatically restart the application. Now in the password generator class, we create a new instance of the Bcrypt password encoder. Encoder equal new Bcrypt password encoder, and the raw password is code Java. Encoded password is the result of the function encoder encode raw password and print out the encoded password to the standard output. Now let's run this program to obtain the Bcrypt format password code Java here. So copy and paste into this editor in MySQL Workbench here, password code Java, and the admin user has password Nimda. Copy and paste into this, and the Alex user has password Alex. Copy, paste here. It is strongly recommended to use encoded form of password. We should not store password in plain text because it is unsecure. Click apply to create these three users in the users table. You see, now we have three users: name, admin, and Alex. And now we assign roles for the users. Username SM has a role user, user admin has a role admin, and user Alex has a role user and editor. So select roles from the users roles table. User name SM has ID 1 and the role user has ID 1. So you see 1. You can see in the users table roles. You can see username SM has user ID 1 and the role user has ID 1. And now for the user admin, user ID 2 and role ID 2. So the data in the users role table is 2. The user Alex has ID 3 and the role user has ID 1 and the role editor has ID 3. As you can see here, ID 3 is for the role editor. So you can see the user Alex has two different roles: role user and role editor. Click apply and apply. We want error duplicate entry user ID 3. There's something wrong to the table. Here we must remove the primary key here. Let me check. Uncheck primary key here for the user underscore ID column in the user's roles table. Apply. We got an error here. Foreign key content is incorrectly formed. Close this. Don't save. Let's check the foreign key row. User. It is correct. Apply. Success. Okay. Now let's insert data again for this user's row table. Select rows. And you can see we cannot edit visually here, so we use the insert statement. Insert into user rows. User underscore ID, row underscore ID, values 1 is for the username HM. Execute this. insert statement. You see one row affected here. And for the user admin, user ID 2, row ID 2, execute. And for the user ID 3, Alex, user ID 3, row ID 1, execute. And row ID 3, execute. And now select all rows from this table, and you see we have the information for the authorization here, row assignment. And next we need to configure data source information to specify the database connection information. So in the project, open the application.properties file here and specify the database URL, username, and password. And here you can see using the database schema salesDB, which is database schema salesDB here. And know that we use this Spring.jpa.hibernate.dll -auto equal none. So upon startup Hibernate, we not create the tables. And next we need to code domain model classes, users, and role to map with the corresponding tables in the database. So create a new Java class here. Class name is user. Finish. It's better to stop our Spring Boot application because we are going to make a lot of changes to the code. And this class has some fields, integer ID and string username and password, and enable, and generate the getter and setter methods for this domain model class user. Source generate getter and setters here, and select all to generate getter and setter method for all the fields. Generate and reformat the code. Format. And we need to use some JPA annotations to map this class with the corresponding user table in the database. And the first annotation is entity from JPA, and the second annotation is table, and we specify the table name is users. And for the ID column, we need to use the ID annotation to specify that this is a primary column, and specify the column name in the database is user underscore ID. And because the values for this field is for this column is auto generated by the database, so we need to use a generated value annotation. And strategy is generation type identity. Okay, that's for the user table. And now let's create the row class to map with the rows table here with only two columns, row ID and name. So create a new Java class. Class row. Finish. ID and name of the row or permission name or authority name, and generate method and set a methods. Select all, generate, and format, and we use the annotation entity and table name equal rows, and to map the ID column, ID field to the user under a row underscore ID column in the rows table. ID column name equal row underscore ID, and generated strategy, generation type, identity. That's it, very simple for the row class. And because the relationship between the users and the rows table is many to many, so we need to write some extra code to implement many to many relationship in the domain model classes. So in this user class, we declare a setup rows private set rows equal new asset to implement the many to many relationship, and we generate the vector and setter for the row set. Yeah, generate, you see. And here we use many to many annotation with cascade type all, and fetch type is equal. So when the user object is loaded, the also associated rows will be loaded as well. And we need to specify the join table. For this many to many relationship. The table name is users underscore rows, and the join column. Join column is user underscore ID, and the inverse join columns. Join column is column or row underscore ID. That's it. That's for the many to many mapping between the user and row. We don't need to do mapping in the row class because we use unidirectional many to many association. So user object, we have a set of rows here. And the next step is to code the user repository class to take the advantage of Spring Data JPA to authenticate the user. Select user by username. So in the project, we create a new interface. Sorry, we need to create an interface, not class. The name of the interface is user repository. and its super interface is the CRUD repository interface defined by Spring Security. Sorry, defined by Spring Data JPA. Okay, finished. And we specify the domain type. Here is the user class, and the type of the ID is integer. Integer is a type of the ID field in the user class here. And in this interface, we define only one method to authenticate the user. Public user get user by username. And we use an embedded JPA query here. The query is select you from user you, where you got username equal parameter username, and in this method we specify the param annotation username, and its variable is string username. And at runtime in the Spring Data JPA, we generate code for implementation of this interface, so we don't have to write any concrete code. Just define this interface, and Spring Data JPA we do the rest, execute our query, and return the user by username. And to use the Spring Security APIs, we need to implement the UserDetails and UserDetailsService interface. First, let's implement the UserDetails interface to provide the user details information to be used by Spring Security. So create a Java class here. The class name is MyUserDetails, and its super interface is user details as defined by Spring Security. Okay, finished. And this class wraps an instance of the user domain model class here. So we create a private instance field user here, and generate constructor using field source, generate constructor using fields, and select what is a field user here, generate, and we have the constructor here. And let's override the method as defined by the user details interface required by Spring Security. Get password, get the user password, user get password, get the username, user get username. For this kind of method, we return true. True is account unlocked, return true. True. And is enable, we return the user is enable method. And for this method, get authorities, we need to provide a set of roles in form of authority. So here we get a set of row from the user object, set rows user get rows, and for each row in the set rows. We create a collection of simple granted authority here. This is a collection of permission to the user. Authorities equal new array list, and here we add a new simple granted authority to the collection for each row. Authorities, add new simple granted authority and the row name of row name. Okay, and return the collection authority. Okay, that's it for the MyUserDetails class. Sorry, here is row.getName, and the second class implements the UserDetails service as required by Spring Secrity to authenticate the user and get the user information based on username. So create a new class here. The class name is User Details Service Implementation IMLPL. Its super interface is User Details Service here. Okay, and in this class we need to override load user by username method, and since we are using Spring Data JPA, so we inject an instance of the user repository interface here. Private user repository, and we use the authorize annotation to let the Spring framework automatically generate implementation and inject an instance of user repository into this class. And here in this load user by username method, we use the user repository user equal user repository get user by username, and we check if user is no, then we throw an exception, throw new username not found exception, could not find user. Otherwise, we return a new instance of MyUserDetails class wrapping the user. Okay, so that's for the UserDetails service implementation class. And finally, we configure Spring Secrity for the authentication and authorization to connect all the pieces together. Okay, so create a new class here. Class name is web security config, and this class should extend the base class web security configure adapter here. Okay, finish. And this is a configuration class, so we must use the annotation configuration from the Spring framework. And to enable Spring Secrity, we need to use the annotation enable web security. And we need to declare a bean for the user details service. Bean public user detail service, user details service, and in this method we return an instance of the new instance of the user detail service implementation, which we have coded. And the second bean is to let Spring know about the password encoder we want to use. Bean public Bcrypt password encoder. We use Bcrypt because it is recommended by Spring Secrity password encoder, and we return a new instance of Bcrypt password encoder class. And next we need to declare a bean for the DAO Authentication Provider. Bean public DAO Authentication Provider. Authentication Provider. And we create a new instance of a DAO Authentication Provider. Auth provider equal new DAO Authentication Provider. And we set the user detail service and password encoder for this DAO Authentication Provider. Set password encoder method, and set user detail service and return this object auth provider. And we need to configure Spring Secrity. Configure Spring Secrity APIs for authentication and authorization. We need to override a couple of methods. So source override implement methods here, and choose the two methods, configure HTTP security and configure with authentication manager builder. These two methods. Okay. And in the first configure method, we set the authentication provider for this authentication provider method. And in the configure with HTTP security parameter here, we configure the authentication and authorization for the application. HTTP authorize request requires that now all the users must be authenticated to use the application. Any request authenticated the users must login, and we use a default login form permit all, so everyone can use the login form. And we also permit all for the logout. Permit all. That's for now. Okay, so far a lot of code has been written. Now let's start our Spring Boot application to see to make sure that nothing wrong. Okay. start our Spring Boot application. Okay, here we go. The application is up and running, and it seems that no problem but startup. Access the application, and we should see the default login form here provided by Spring Security. And let's try to enter wrong username and password, and we got the error bad credentials. Now I log in with the user. You see we created 3 users: name SM, admin, and Alex. Now let me log in with the user name SM, password, code Java. Here we go. I have successfully logged in to the product manager application. And you see we need to display the username of the logged in user in the top of the page here. So we need to use Thymeleaf integration with Spring Security API. So we need to declare an additional dependency in the Maven file here for Thymeleaf integration with Spring Security dependency. And the group ID is org Thymeleaf.actors, and artifact ID is Thymeleaf dash actors dash Spring Security 5. Save the change, and now let's edit the home page of the application in the index.html file here, and to use the syntax of Thymeleaf for Spring Security authorization, we need to declare XML namespace here, XML and sec equal https thymeleaf.org/thymeleaf dash actors dash Spring Security 5. And for authenticated user, we display the username and logout button. So we use a deep section here, and we use the sec::authorize, and the method is authenticated. So only authenticated users can see this section, and the welcome message following by the username. And to display the username using Thymeleaf, we use the sec authentication and equal name. Username is a template. Save the change. Refresh. Now let's log in again. Name is code Java, and you see the welcome message, welcome username. So authentication equal name. I think we need to stop and restart the whole application. Sec authorized is authenticated. Sec authentication equal name Thymeleaf or Thymeleaf actual Spring Security 5. Okay, Let's check the dependencies jar file. Here, make sure that Thymeleaf actual Spring Secrity file here. Okay. Now start the application. Okay. Refresh and log in again. And you see it displays the username name SM here. Very good, right? We want to make the username in bold. So write the span tag here inside B tag here. And you can see welcome name SM. And we can display the role names of this user. User span tag rows and user command sec authentication equal principal dot authorities, and it will display the row. Let me see, principal dot authorities. My mistake, authentication here. And you see it displays the row name after the username here. Now let's add the logout button. Logout button, we must use the form to use HTTP post request th action equal logout method equal post, and we have a logout button here. Input type equal submit value logout save. And you see the logout button here, and you can click here to log out. And you see you have been signed out. And now let's sign in with the user admin. You can see welcome admin, and the role name is admin here. Log out and let's log in with the user Alex. And you can see this user Alex has two rows, editor and user here. So far so good, right? Now let's authorize the users to use the specific functions of the application based on this permission details. The user having the role user can view only the product list, and editor can view create and edit products, and admin can view create and edit and delete products. So in the Spring Secrity configuration file here, we need to write some code to authorize the users based on URL. Use a method and matches and specify the URL. For example, only the admin can delete a product, so for this URL the user must have the authority. As you can see, we have also has a row. The difference between the has row and has authority method is that the has the row method automatically insert the row underscore prefix to the row name, whereas the has authority method doesn't append the prefix. So because in the database we have the row name without the prefix row, so we need to use the has authority method and the row name here without the prefix has authority admin. And for edit products, only the user has rows admin or editor can edit product. So we user has any authority method here, and with this method we can specify a multiple row names here, admin and editor can edit products. And the reason I need to use a wildcard asterisk here, because in the controller class you see the URL edit followed by ID of product, and delete followed by ID of product. Also, as you can see in the edit hyperlink here. So this is a code to authorize the user based on the rows you see, and save the change. Now let's log in again with the user name HM and create new product. This user can create new product with the user with the row user, but cannot edit. You see, I got the error message for HTTP status forbidden and for 3 here, because this user doesn't have permission to edit or delete. You see. Now log out and let's log in with the user Alex, who has a row editor and user. And Alex can create new product and edit product. Let's update this product. The price is 199. It is updated and try to delete, and you see I got error here because the user with the row editor doesn't have permission to delete. Only the users with the row admin can delete products. And we want to customize the error page here for unauthorized error message. To do so, in this method we code and exception handling access denied page and specify the URL for the access denied page, for example 43, and we need to map this URL with a view name, view template, create a template here, HTML 43, and finish. And the title is access denied. The message is sorry, you don't have permission. You don't have permission to access this page. And in the controller class, create a method to return the view name for that URL, red mapping for 3. public string error 43 and just return the view name 43. That's it. Save all the changes. Now let's log in again with the user Alex. And you see the URL delete here with the user Alex who doesn't have permission. Admin, what error? Sorry, you don't have permission to access this space. This user can still use can still view products and create new products. For example, create new product brand for brand Xiaomi made in China 49, and you see new product here and edit update the price to 39. Save. You see updated but cannot delete. You don't have permission to access this page. Now we want that the users can see only the action that they have permission to do. So this Alex user can see only the hyperlink to edit, not see the delete hyperlink. And the user name SM, we see only the product list and create new product. And this user with the row user won't see the actions edit or delete. And we need to update the Thymeleaf view here. We see for the actions column table heading action here. And to authorize the user, we can use the Thymeleaf security syntax set authorize equal. Here user method has any authority as same in Java code, and we specify one or more row names here. And because the user admin and editor can see the action column, so we call this method as any authority with the row names admin and editor. And scroll down for the table data here. There's the edit hyperlink here. And we also need to use a sec authorize method has any authority and row names admin editor. And because only the admin user can delete product, so here in the hyperlink here we can use Thymeleaf security tag authorize as authority, and this time we use a has authority method that takes only one row name, row admin. That's it. Save. And you see this username SM doesn't see the links to edit or delete product, only the link to create new product and the product list. And now let's log out and sign in with the user admin. And you see the user admin can create new product, edit and delete normally. Let's try to delete a product here. You see, log out, and let's try to now this time log in as the user Alex, who has a roles user and editor. And you see, this user can see only the link to edit a product here. So far so good, right? So far you have learned how to secure web pages and implement role-based authorization for Java application based on Spring Framework using Spring Security APIs with Spring Data JPA, Hibernate, and MySQL. I hope you will find this tutorial helpful. Please click subscribe, like, comment, and share this video. I am Nam Amin from CodeJava.net.